You are standing in your hallway on a blistering July afternoon, holding an energy bill you cannot explain. The solar fan is spinning up on the roof right now. You can hear it, a steady mechanical hum above the ceiling. Last month, you spent $400 on that machine because the box promised lower cooling costs and a cooler house. The bill in your hand says your air conditioning ran harder this month than any month last summer. Something is moving backward. That fan is supposed to be winning, and instead, it is costing you more every single day it spins in the sun. You need to ask one question the manufacturer never asked for you. A fan pulls air out of the attic. Fine. Where does the replacement air come from? That question is the entire problem, and it is also the entire fix. Most homes in the country were not sealed with any meaningful attention to the boundary between the living space and the attic. The ceiling plane is crossed by ceiling penetrations, such as recessed lights and plumbing chases, along with electrical runs and attic hatches that were never made airtight. None of this was a serious problem before the fan arrived. Air drifted lazily through those gaps because there was no force pushing it anywhere. The moment you mounted that solar fan and aimed it at the sky, you changed the physics of the entire house. The cost of this change is not abstract. It shows up in 2 columns on your energy bill, and in a 3rd column, nobody prints, which is the accelerated wear on your central cooling system. Your air conditioner was designed to run in cycles. It starts, it cools a defined volume of air, it shuts off. When the Department of Energy field-tested homes with powered attic fans over unsealed ceiling planes, the monitoring equipment showed extended run cycles compared to baseline. The air conditioners lost the efficiency of the compressor's normal start-stop rhythm. A compressor, cycling on for 45 minutes at a time instead of 15, is a compressor absorbing heat. It was not rated to absorb. The refrigerant lines sweat and the condenser motor strains. The outdoor unit ages faster than it should. You are spending money on electricity to run an overworked machine, while the solar panel on the roof runs the fan for free. That is the cruel arithmetic. The fan costs nothing to operate, and the air conditioner costs a fortune to compensate. There is also a second cost that arrives without a receipt. Hot, humid outdoor air is being pulled into the living space to replace the conditioned air the fan is extracting. That outdoor air carries moisture. Moisture in a cooled house condenses on surfaces, on ducts, on wall cavities behind the drywall. The Building Science Corporation has published research showing that mechanical depressurization of an attic above an unsealed ceiling reliably increases moisture infiltration into the conditioned space below. Moisture is the foundation of mold. You're not just paying a higher electricity bill, you're slowly loading your walls with the raw material for an expensive remediation problem. The logic that sold you the fan is not stupid. It sounds correct because it is built from true pieces assembled in the wrong order. Hot roof shingles superheat the air trapped in the attic. That attic air can reach temperatures the Building Science Corporation has documented at 130 to 150 degrees Fahrenheit in summer. At those temperatures, radiant heat pushes downward through the ceiling into the rooms below. A fan that removes that hot air should break the cycle. Cool air flows in from the soffit vents. Hot air exits through the fan. The house stays cooler and the air conditioner rests. It is a clean picture. It is also wrong in one critical and non-negotiable way. The picture assumes the replacement air comes entirely from outside the house, entering through the ventilation openings at the roof's edge. Soffit vents, however, are frequently blocked by insulation that has been pushed to the perimeter of the attic floor. The Department of Energy notes in its ventilation guidance that a significant percentage of soffit vents in existing homes are partially or fully obstructed, dramatically reducing the available free ventilation area. When the outside path is restricted, the fan does not slow down. It pulls harder. It finds the next path of least resistance, and in most houses that path runs straight through the ceiling. Air does not follow the route you drew for it on the back of the packaging. Air follows pressure gradients. The fan creates a zone of lower pressure in the attic. The living space below sits at a slightly higher pressure. Pressure difference drives flow. The cold, dense, conditioned air in your hallway and bedroom is now the fuel source for the fan's appetite, and it moves upward through every gap it can reach. This is the real mechanism, and it was documented precisely. The Building Science Corporation describes the process as induced infiltration from the conditioned space, meaning the fan does not just ventilate the attic, it ventilates the house. The fan pulls conditioned air upward through ceiling penetrations, such as recessed lights and plumbing chases, and expels it into the neighborhood. The Department of Energy's research into home energy performance lists powered attic fans installed over poorly sealed ceilings as one of the most reliably counterproductive upgrades a homeowner can make. The mechanism is not subtle. It is not occasional. It runs every minute the sun shines on that panel. Here's where the situation compounds itself into something genuinely damaging. The unsealed ceiling is not simply a neutral participant. It is an active partner in the loss. Think about the cumulative open area created by all of those gaps around lights, pipes, wires, and the hatch combined. The Building Science Corporation's building diagnostics research suggests that in a typical older home, the total unsealed area at the ceiling plane can equal the area of a fully open window. Picture running your central air conditioning on the hottest day of July with a window open in the living room. That is the condition your house has been in every afternoon since you installed the fan. Without the fan, that open window analogy still applies, but the stack effect driving air through the gaps is gentle and bidirectional. Some conditioned air rises out, some outdoor air seeps in. The process is slow enough that the air conditioner compensates without drama. The fan eliminates the gentleness. It replaces the soft, slow movement with a sustained mechanical suction. Every crack becomes a high-velocity leak. The cold air the compressor just manufactured exits faster than the air conditioner can replace it. The thermostat reads rising temperatures, calls for more cooling, and the fan immediately harvests and discards the new cold air. The ceiling acts as the intake manifold for the fan. The harder the afternoon sun drives the panel, the harder the fan pulls, and the faster the already cooled air disappears into the hot attic above. You have built a machine that converts sunlight into wasted refrigeration. The second variable, the poor ceiling, transforms an imperfect product into an active drain on your finances. To confirm that your solar fan is pulling conditioned air through the ceiling, run this test on a hot afternoon while the fan is operating at full speed. Light a candle and hold it near the ceiling. Penetrations you can reach from below. The trim ring of any recessed light fixture, the perimeter of the attic hatch, and the collar around any plumbing vent or electrical chase. Keep the flame near the trim ring, not aimed into the opening. If air is moving from the conditioned space into the attic through that point, the flame will bend consistently toward the fixture housing and hold that deflection rather than burning straight and recovering. A sheet of tissue held at the same openings shows the same movement with equal clarity. Any location where the flame or tissue bends persistently toward the ceiling is a point where your air conditioner's output is feeding the fan. Mark those locations. Now comes the sequence that actually fixes the problem. The sequence matters more than any individual step, and the sequence must never be reversed. Start with $0 spent. Go into the attic on a cooler evening when the wood is safe to touch. Move the insulation bats away from the perimeter and from around any ceiling penetrations. You will find the gaps that the candle identified, now visible from above. Foam, backer rod, and a can of expanding foam sealant, which together cost less than $30 at any hardware store, will seal the large gaps around plumbing stacks and wall plates. A tube of acoustical caulk handles the smaller cracks around electrical boxes and junction covers. Work methodically from one end of the attic to the other, sealing every place where the living space connects to the attic air. Use foam board cut to size to build an airtight dam around recessed light housings that are not rated for direct insulation contact. Push the insulation back into place when you finish. After sealing, wait 1 full week and run the candle test again. A properly sealed ceiling will show no upward flame movement at any fixture. The house is now a closed envelope. Only after you have confirmed the seal should you revisit the question of attic ventilation. The Building Science Corporation's analysis of passive versus active attic ventilation shows a finding that will surprise you. A continuous ridge vent paired with open soffit vents moves adequate air volume through the attic without creating negative pressure. It consumes no electricity and requires no mechanical equipment to maintain or replace. The natural buoyancy of hot air drives it upward and out through the ridge, while cooler outside air enters continuously at the soffits. No pump, no panel, no $400 purchase. The Department of Energy's ventilation research reinforces this point. Ridge and soffit systems maintain consistent airflow through the attic cavity across the full range of outdoor temperatures without any moving parts subject to wear or motor failure. The Building Science Corporation adds that passive systems also avoid the pressure differential problem entirely because they do not generate suction. They simply allow buoyancy-driven air exchange to proceed at a rate governed by temperature difference and not by a motor rating. If your home already has a continuous ridge vent and clear soffit vents, you already own the superior system. The solar fan is redundant at best and destructive at worst. What you must never do is skip the sealing step and simply add the fan, or reinstall a fan you removed without first completing the air seal. The Department of Energy's guidance on attic ventilation is explicit on this sequence. Mechanical attic ventilation in the presence of an unsealed ceiling boundary is counterproductive and will increase whole house energy consumption. A fan on top of a leaking ceiling does not add to a passive ventilation system. It corrupts it. Installing the equipment before addressing the envelope is the $400 mistake this episode began with. If you purchase the solar fan and it is currently mounted, you have 2 paths. The first path is to complete the air seal as described and then leave the fan in place. Once the ceiling is tight, the fan may provide modest supplemental benefit without causing harm. The passive ridge and soffit system will likely match its performance at no cost. The second path is to seal the ceiling, confirm through the candle test that the envelope is closed, and then evaluate whether attic temperatures during peak afternoon hours are acceptable. If you have a sealed ceiling and a working passive system, attic temperatures will still be high in summer. The Building Science Corporation's field measurements show those temperatures can exceed 100 degrees Fahrenheit during peak afternoon hours. But the heat will not be moving into the house because you have closed the door between the two spaces. The bill in your hand does not have to be the bill you receive next month. Seal the ceiling first. Let the physics of natural convection do the ventilation work for free. The fan may stay or go, but it can never lead. It can only follow a house that has already been made whole. The fan is still on the roof. Now you know whether it is working for you or against you. If you have a powered attic fan, hold a piece of tissue near your highest recessed lights while it runs and tell me in the comments which direction the tissue moves.